Hello everyone, I'm Marlene Cramer and I'm working at Edinburgh Napier University in the In Future Wood project. The project focuses on the possibility of reuse of timber in construction and asks, how should we build today to be able to circulate tomorrow? To answer this question, we took a step back and tried to find out, how did we build yesterday and why is the reuse of timber from today's buildings inhibited? For this purpose, my colleague Dan Ridley-Ellis and I had a look at the demolition industry in the UK and at the timber that results from demolitions. This is the Tor Christian Nursing Home, situated in Edinburgh's Corstorphine Conservation Area, in a big garden between the historic Torwood House and its stable block. It can host up to 50 residents and in addition offers a cafe, a courtyard with water features and a garden with many mature trees. Could you imagine spending your old days here? Well, no matter your answer, you can't. The building has recently been demolished. Why, you ask? The building looks good after all. You're right, the building is not too old. It was only built after 1988, and parts of it are only 14 years old. However, the nursing home already closed in 2016 for financial reasons. Shortly after, investors started presenting plans for transforming the site for residential use. This includes the conversion of the historic Torwood House and its stable block, the erection of 2 new building blocks with a total of 23 flats, and it does not include the nursing home building. Its fate was decided in 2017, and the execution started in August of 2020. The demolition contractor was Charmic, and the demolition manager, Michael Hunter, generously took us around the site and answered all our questions. Here you see the building in the soft strip phase. Parts of the structure are already exposed, and we can see that it's made of light timber frame, despite the outer concrete appearance. This is part of the 2004 extension. The timber looks good as new, doesn't it? This is a glimpse under the ceiling covers in the ground floor. We see the first floor joists and a lot of service installations, like cables and tubes. Some of them are attached to the timber too. All valuable materials are salvaged before the demolition, but in this case there was not a lot of value. A few of the solid wood doors and some natural stone and a bit of medical equipment was removed for reuse. The door frames and handrails were removed as well, but only because the demolition machines cannot separate these materials during the demolition process. The door frames are simply removed with a crowbar. Afterwards, the wood is in no condition for reuse, and it goes to wood recycling. Surprisingly little other fittings are removed. Lamps, wall tiles, sinks, toilets, smoke alarms, and radiators remain in the building. This is the building 4 weeks later, already 75% demolished. Michael Hunter explains that it is very important for demolition companies to segregate materials so they can be recycled, but most things can and will be separated by machines. He estimates that more than 99% of stone, timber and metal are recycled, and only 1 skip of waste goes to landfill for every 3 to 4 skips that are sent to wood recycling. Wood recycling in that case means chipping and using the material in particle board, animal bedding and biomass for energy recovery. The condition of the wood is obviously not important for the wood recyclers, and therefore it isn't important for the demolition companies either. Most timber is extracted using an excavator with a hand-like tool that grabs building parts and pulls or simply shoves them out of the building. The material is usually damaged in this process. The excavator can also separate materials afterwards. For example, here it removes roof felt from the timber. Smaller material contaminations are removed by hand, but not the very small things like fasteners. These can be sorted out after chipping. And there are a lot. Nails and nail plates and screws from the connections of beams and boards, but also fasteners that attached service installations to the timber. It would be a challenge to find even 1 meter of clear wood in most of the timber members. Michael Hunter says that the demolition industry used to work in a different way. They used to salvage all material for reuse, but this business model isn't profitable anymore because new materials are very cheap nowadays and there is no market for recovered materials. The deconstruction of buildings would not only not be economically feasible, but new health and safety measures wouldn't allow it either. Time is now the most important factor to consider in a demolition project. So all materials are extracted really quickly, but in no condition for reuse. They are mostly recycled at basic material level. Timber as chips, stone and concrete as backfilling material, and gypsum board as cat litter. And so it takes only 4 to 6 weeks for an inhabitable building to be disintegrated into a few waste skips. It takes only seconds for a timber beam that supports a roof to splinter and lose all its potential. But buildings contain materials that are growing more and more scarce. Even timber, though it is renewable, cannot grow fast enough to satisfy our demand. And it's very likely that we will need to reuse the materials that we are putting into buildings today. So which steps do we need to take to make the building industry more circular? Well, the design of whole buildings as well as building components seems to be most important. Remember that the nursing home only got demolished because it didn't serve the required purpose anymore? It is quite common that buildings get demolished because they are in the wrong place at the wrong time. If we could build more modular and make buildings adaptable for different uses, we could probably avoid some of these demolitions. For the buildings that still need to be removed, we need to think about design for deconstruction. We can easily imagine that the demolition machines are precise enough to lift off building parts without damaging them, if only they were connected to other members in a reversible way. At the moment, connections are using nails excessively, but maybe we could rely more on form-fitting or screwed connections, at least between functional groups. We also saw that a lot of fasteners result not from structural connections, but from service installations. This could also be solved in a reversible and more adaptable way, and a higher level of prefabrication in building construction will be beneficial for this development. There are many ideas for design for deconstruction of timber elements, and in the In Future Wood project we are developing even more. So it's on all the manufacturers of prefabricated building parts to use them, and on all the designers and architects to develop buildings for the future that actually reach their full lifespan. Thank you for watching.